like I said, the sum and difference identities were things we learned on Monday that could help us find angles that were not on the unit circle. These half angle identities that we'll learn about today will also help us find angles that we're not familiar with and ones that we don't know the value of because they aren't on the unit circle. And so, likewise, there's many more trigonometric identities we haven't learned. These are a couple of them, these half angle identities, and we'll see how they can help us. So these are our half angle identities, where it would be like sine of theta over 2 is going to equal plus or minus the radical 1 minus cosine of theta over 2. First thing you need to notice is this theta that is in the identity. That is the theta that is over the 2. So this isn't, or this theta isn't our original angle we're given. This is an angle we're going to sort of find that's on our unit circle, so we'll be able to take the cosine of it. It might be slightly confusing at first, but we'll work through an example, and like the other day, we'll try to work through with something we know first. That way we can see how it works, and then we'll start to do stuff that we don't know. The plus or minus, this doesn't mean that you take both the positive and negative value of this angle. So just as sine can have a positive in the first quadrant, positive in the second quadrant, a negative in the third quadrant, and a negative in the fourth quadrant, if our angle that we're looking for is in the third quadrant, we would take a negative of this radical 1 minus cosine theta over 2. If it was in the second quadrant, would we have a positive or a negative in front? What do you think? It's going to be a positive because it would be in the second quadrant and sine is in positive in the second quadrant. So we have to not only know where these new angles lie, but we have to know the sine and cosine value to figure. We have to know which values these sine and cosine, or what quadrant sine and cosine are in order to determine whether this angle is going to be a positive or a negative. So that's what the plus and the minus in front represents. On tangent, it has, you can't have cosine of theta equal to -1. Do you know why we can't have cosine as -1 for tangent? So you can't take square root of a negative, but we want to get a negative in the top. If we had -1 in the denominator, it'd be 1 plus -1, which is 0, and we can't divide by 0. So that's the only reason why we can't take the tangent of, or have cosine equal to -1 for tangent. And cosine of -1, that happens at pi. If we would look, it would be the pi of, or pi over 2, which pi over 2 for tangent is undefined. So it shouldn't be given to you anyway, so you typically won't have to worry about that. But at some random case, if you ever use this in the future, just remember you can't have cosine as -1. But we're going to work through some examples, or like an example of this to start off with something familiar to us to see how they work, and then we'll do some things that are unfamiliar to us. So we're going to determine the exact value of cosine of 60 using the half angle identity. So the first thing we want to use is we want to determine which formula we want to use. This is fairly easy. If it tells you cosine, we're going to use cosine. If it tells you sine, we're going to use sine, tangent, tangent. That shouldn't be the hard part. So because we have cosine of 60, we're going to use cosine. Step 2 is to determine whether cosine of 60 is going to be a positive or a negative angle. So is our cosine of 60, 60 is in the first quadrant, is 60 positive, or is cosine positive or negative in the first quadrant? Positive. Positive. So we know our answer is going to be positive. So that would be step 2. You'll never get done with the unit circle. We're always going to keep using it. So don't let that thing drift off in the back of your head. I know. Thumbs up, right? So step number 3 is we're going to use our formula. Something we need to be careful with is that theta in the formula, it's twice the angle that we're looking for. So if we looked back at our examples, it's theta over 2. That theta is twice the angle we're looking for. So the reason we divide by 2 is because we're multiplying it by 2 at the same time. So 60, that theta we would use for cosine of 60 is going to be 120. Because 120 divided by 2 is 60. That might still seem confusing, but in the example, hopefully it'll clear up. So, and then the final thing is we want to make sure our answer is in the exact form. So we want to make sure we don't have any radicals in the denominator, which we're going to talk about, which we didn't talk about on Monday. But we're going to talk about fixing that, and then just simplifying it as far as you can. And if you want to check, you can pull out your calculator and you can type in, like, what is the cosine of 60 on your calculator, and then you can type in the answer we have and see if they equal the same. Cosine of 60, though, shouldn't be something you're probably typing in your calculator because that's something you should have memorized. But that's just for right now. We'll talk about some other angles we don't have memorized. So we'll get started with this example. So once again, the cosine of 60, that's what we're looking for. We should know the cosine of 60 because it is on a unit circle. What is the cosine of 60? 1/2. 1/2. So even though typically we don't know the angle because it's not on a unit circle, but in this case, because we're just showing an example on how these work, we know our end goal or our answer should be 1/2. Typically we don't know that, but just for this problem, to show it. So the first step we do is we take twice the angle we have and put it over 2. So 60, twice of 60 is 120, and then we put it over 2, because 120 divided by 2, that's still 60. So we still have the same angle. This isn't different in any way. It's still cosine of 60. We just wrote it a little bit differently in order to use this identity. And so our identity, we know it's going to be positive. We're going to use the positive one because we know cosine of 60, that gives us a positive number because cosine is positive in the first quadrant. So we don't have to worry about that plus or minus in front. Yes, Gracie? Yes.
I'm going back to the bottom one, I'm sorry.
Mm-hmm.
It says like cosine 60 equals cosine 120 over 2. So with that top one, I use cosine and then 2 theta over 2 because he multiplied it by 2.
So we're going to fill, or we know it's a positive angle because it's in the first quadrant. We're going to fill in this box with what our theta is. So in this case, it's 120. So we have the radical of 1 plus cosine of 120 over 2. This theta is always going to be the theta that is over your 2. It's not going to be your original angle we started with. So it's not going to be cosine of 60 inside the radical. It's going to be cosine of 120. So now that we know what this is, we can solve for it. So we should have 1 in our numerator, and then this is going to be plus the cosine of 120. So we know what the cosine of 120 is. That's on our unit circle. Does anyone remember what it is? Negative. Yes, yeah, negative 1/2. I had to think for a second because it's not in radians. But cosine of 120 is negative 1/2. And that's over 2. So all we did was we changed, or we took the cosine of 120 and just filled it in. And now we just have to solve. So what is our numerator going to become? What's 1 plus negative 1/2? Or 1? Yeah, it's just going to be 1/2. 1 minus 1/2, 1/2. You have $1, take away 50 cents, get 50 cents. And now we have 1/2 divided by 2. What is 1/2 divided by 2 going to give us? 1/4. So we have the square root of 1/4. And does anyone remember how we take the square root of a fraction? We take the square root of the top over the square root of the bottom. So it's going to be the square root of 1 divided by the square root of 4. So what's the square root of 1? 1. And what's the square root of 4? So I already said it. My brain thinks faster than my mouth sometimes. So our answer is 1/2, which we know is right because we already know what the cosine of 60 was. So this problem may seem irrelevant because we already know what the cosine of 60 is, but if we were given the sine of 105, this is an angle we don't know. So this is where it becomes more relevant to us. Do you guys need me to go back? I know I just switched pages really fast. You're good? All right. So we don't know the sine of 105. That's not an angle we know. But we can use this half angle identity to help us find that. So the sine of 105, that is the same as the sine of 210 over 2. We take our angle, we multiply it by 2, and then we set it over 2. These are the same thing because 210 divided by 2 is just 105. And now that we have our form or our question in this form of sine of 210 over 2, we can use our half angle identity to solve it, to figure out what the sine of 105 equals. So we then rewrite it as 1 minus the cosine of 210 over 2. But something we need to remember before we start solving this is 105, what quadrant is that in? What is 105, or is sine of 105, is that going to be a positive number? Is that going to be a negative number?
Well, in the second quadrant, but
So,
sine will be positive.
105 degrees is in the second quadrant because it's just a little bit above 90. And so it's going to be in the second quadrant. Sine is positive in the second, so we know this is going to be a positive answer. So we really don't have to write anything in front of this square root because that plus in there doesn't really mean anything. But that's just there to remind us that it's a positive number. So now that we know it's positive, we can start to solve the inside. So what is the cosine of 210 going to be?
Negative radical 3 over 2.
Negative radical 3 over 2. So we have 1 minus negative radical 3 over 2, all divided by 2. So we just took the cosine of 210 to get negative radical 3 over 2. So a negative minus a negative, or when you subtract by a negative, this is the same thing as making it into a positive or adding by a positive. So it's really 1 plus negative, or 1 plus radical 3 over 2, all divided by 2. Is there any way we can simplify this numerator? Sorry, Tracy, do you need to scroll up?
You're fine.
So is there any way we can simplify this numerator of this fraction? We could, yeah, so what do we need to do in order to combine these? We need a common denominator. So what would our common denominator be between 1 and radical 3 over 2? It's going to be 2. And so what will 1 become then? Yeah, it's going to be 2 over 2. So we have 2 over 2 plus radical 3 over 2 is all divided by 2. I know it doesn't look like because of how I wrote my square root, but this 2 is under the square root as well.
How does that become 2 over 2? Or is that just...
So 2 over 2 is the same as 1. It's just with a common denominator. It's just with a denominator of 2 for us. That way we can add these together. Because now that they have a common denominator, we can add the fractions by just adding their top, or their numerator. So we have 2 plus radical 3 divided by 2, all divided by 2. So all we did was we took our numerator and turned it into one big fraction. Sorry, Tracy. So 2 plus radical 3 over 2 divided by 2. What does that simplify to? Sorry, that was a lot of 2's. We can't cancel out these 2's. So this is, the 2 in the denominator is the same as 2 over 1. So when dividing by fractions, don't ask why, just flip the second, multiply. So we're going to have 2 plus radical 3 over 2 multiplied by the reciprocal of our denominator, which is going to be 1 over 2. Now what does this become? So when we multiply fractions, we multiply straight across, so top by top, bottom by bottom. So 2 plus 3 multiplied by 1, anything multiplied by 1 is itself, so we'll have 2 plus radical 3 on the top, and then 2 times 2 is 4 in our denominator. Ooh, too far. Now can we simplify it any farther? See some heads shaking, and what can we do? Go ahead.
So we'll simplify the two.
So we can't cancel anything out or simplify anything because this is being added. So we can't do anything at the moment in that case. Thomas?
You can square root or you can square root plus radical 3.
So we can change this as the square root of 2 plus radical 3 over the square root of 4. And we know the square root of 4. We might not know the square root of 2 plus radical 3 because that's an ugly irrational number. But we can simplify the square root of 4. So that's going to be 2 plus radical 3. And then what's the square root of 4? 2. And so it's the square root of 2 plus radical 3 all over 2. That would be our final answer for the sine of 105. I know it looks really ugly and it doesn't look like it should be a real number. It's like we just threw a bunch of stuff on the board. But that's why we didn't have you memorize these like off-angle identities or these off-angle values, because there's no way you're going to tell, I'm going to ask you like, what's the sine of 105? And you're going to say radical 2 plus radical 3 or the square root of 2 plus radical 3 all divided by 2. Like there's no way we'd test you on that. So that's why we have these half-angle identities to help us know these angles that we don't know off the top of our head. Are you guys okay to move on? Very good. So tangent of 3 pi over 8. Once again, 3 pi over 8, this isn't on our unit circle. We don't know those values. So we're going to turn it into something that we do know in order to solve for it. So using our half-angle identity, we can rewrite the tangent of 3 pi over 8 as the tangent of, we would multiply the top by 2 and put it over 2. So what's 3 pi over 8 times 2? It's going to be 6 pi over 8. But then 6 pi over 8, we can simplify that to something we know. What is 6 pi over 8 simplified to? It's going to be 3 pi over 4 divided by 2. This is the same as tangent of 3 pi over 8. We just rewrote it in a different way that we can solve for. So it should be 3 pi over 4 divided by 2. So before we move on, is 3 pi over 4 or 3 pi over 8? What quadrant is that in? Not 2. It's actually going to be your first quadrant. So if you have trouble trying to think, so pi over 2, that would be half of it. That would be 4 pi over 8. And so 4 pi over 8, it's just a little bit less than that. And so it's in the first quadrant. Another way to think about it is you could take 3 divided by 8. You can find whatever that decimal point is. If it's less than 0.5, it's in the first quadrant. If it's in between 0.5 and 1, second quadrant. It's in between 1 and 1.5, it's third quadrant. If it's in between, what's the other one? 1.5 and 2 is fourth quadrant. That's a quick way of figuring out that. But otherwise, you just sort of have to think through your head what quadrant is this going to be. But it's in the first quadrant. So what's tangent for the first quadrant? Positive or negative? Positive. So we know we're going to have positive 1 minus the cosine of 3 pi over 4, because we're using that new angle that we know, over 1 plus the cosine of 3 pi over 4. Are you okay, Gracie? What? It's the tangent.
We don't have to say for the 2.
That, so we changed 3 pi over 8 into 3 pi over 4 divided by 2. And just like in the last one, when we did 105, we turned it into 210 over 2, and we only worried about the 210. So now we're only going to worry about the 3 pi over 4, because that's something we know. And so now we can just take the values of cosine of 3 pi over 4. Does anyone know what that's going to be? not negative
Oh, just
1.
one.
It's going to be
Square root of 2.
just square root of 2 over 2.
No.
Negative square root of 2 over 2, because it's in the second quadrant, so cosine's negative in the second quadrant.
Oh.
So it's negative radical 2
I was thinking.
over 2 is our cosine of 3 pi over 4. So what is our numerator going to simplify to? Or, first of all, we have a negative, or we are subtracting by a negative, so what's that going to be? It's going to be adding by the positive. So we have two negatives, we can turn it into a positive. What's our common denominator for 1 and radical 2 over 2? 2. So we can change 1 into 2 over 2 plus radical 2 over 2. And likewise, in our denominator, we can change it into 2 over 2 minus radical 2 over 2. The minus is from this being a negative. So when we add by a negative, it's the same as subtracting. And then we just changed our 1 to 2 over 2 to get that common denominator, so we can start combining these fractions together. So what would our numerator simplify to?
2 plus radical 2.
It's going to be 2 plus radical 2 over the common denominator, which is 2. And then our denominator is going to be likewise. It's going to be 2 minus radical 2 over the common denominator of 2. I know there's a lot of 2's in this problem.
And then do we multiply? Like,
When we divide by fractions, we don't ask why, we just flip the second and multiply. So in order to simplify this, we're going to have the square root of 2 plus radical 2 over 2. We're going to multiply by a reciprocal. And so it's going to be 2 over 2 minus. And what do you notice can simplify here? So we have a 2 in our numerator and a 2 in our denominator. So those can cancel out. And we'll be left with 2 plus radical 2 over 2 minus radical 2. So this is an answer for this problem. That's correct. It's not wrong. But what do you not like about it? We have a radical in our denominator. And mathematicians don't like the radical in the denominator. It's like answering a question but misspelling the word. And so it's not wrong, but it just doesn't look good. So in order to fix this, in order to get rid of this radical in the denominator, we're going to use something that we've slightly introduced before. We're going to multiply by the conjugate. Does anyone remember what the conjugate was? The conjugate, or multiplying by the conjugate. It was something we introduced in trig verifications. So when we multiply by the conjugate, we multiplied by, or it was when we multiplied a fraction by the same thing, either the same top or the same denominator, we just flipped the sign in the middle. The thing we're trying to get rid of is this radical 2. So we're going to focus on multiplying by the denominator. We're just flipping the sign. So we're going to multiply the top and the bottom by 2 plus radical 2. We're going to multiply the top and the bottom. So 2 plus radical 2 over 2 plus radical 2, that's the same as 1. We're not changing our answer in any way. We're just shifting it a little bit to be able to get rid of this radical out of our denominator. Yes. So having to multiply this conjugate does make the work a little bit tedious, because we're going to have to start FOILing and doing a little bit more to simplify it. Even though we have the right answer, we're just rewriting it to make it look nicer and to be a more correct answer. So in order to multiply these, we're going to have to FOIL them. So we remember FOIL is first, outer, inner, last. So to start off, we're going to do first. So 2 times 2 is going to be 4. Outer, 2 times radical 2 is going to be 2 radical 2. Inner, 2 times radical 2, or radical 2 times 2 is going to be another 2 radical 2. And then last, radical 2 times radical 2, what does that become? It's radical 4, which becomes 2. Our denominator, we're going to do the same thing. So outer, or first, is 2 times 2, is 4 again. Outer is 2 times positive radical 2, so we have 2 radical 2. Inner, negative radical 2 times 2, that's going to be a negative 2 radical 2. So we'll see this cancel out. And then negative radical 2 times positive radical 2, what is that going to be? It's going to be negative 2, because it becomes a negative radical 4, which simplifies to a negative 2. And now that we have all these terms all folded out, we can start to collect our terms and see if things cancel out. And I think Ethan already noticed something. We have a positive radical 2 and a negative radical 2 in our denominator. These can cancel out. But we don't have anything that cancels out in our numerator, so we're just going to have to collect these terms. So what does our numerator become?
4 plus 2 radical 2.
So we can collect any like terms. So 4 and 2, these are like terms. That's going to become 6. 2 radical 2 and 2 radical 2, those are also like terms because they both have that radical 2. So what do they become? 4 radical 2. So when we add radicals, if they have the same radicand, which is the number that in the radical, we just add the coefficients in front. So 2 plus 2 is 4. Then what does our denominator become?
2.
2. So we canceled out the positive radical 2 and the negative radical 2. We're left with 4 minus 2, which is just 2. So are we done yet? One more step. So we have an even number. 6 is even, 4 is even, 2 is even. What can we do? We can simplify it. What can we take out? 2. These can all be divisible by 2. So it becomes 3 plus 2 radical 2 over 1. If you were to divide them all by 1 and simplify it. And so we really don't have to worry about that 1 in the denominator. So it's just radical 3, or square root of 3 plus 2 radical 2. And that is your answer. Yeah. Come on. So before you've talked about, or we've asked if we can cancel out like these 4s right here. Why wouldn't these 4s cancel out? Because you have a 4 in the numerator and a 4 in the denominator. And I've always said because they're adding. So the reason we were able to simplify something right here, even though they're adding, is because we simplified 6 and 4. We took a 2 out of each of them, or we factored out 2 from our numerator and canceled it out. Did that help a little bit? You can say no. So what we really did was we changed this to 2 times 3 plus 2 radical 2 over 2. So in order to cancel out this 4 and this 4, we would have to factor out a 4 from each of these and factor out a 4 from all of these as well, which we just can't do. We don't have that. We could factor out a 2 from all of them and a 2 from all of them like we did down there, but that's just going to be a little bit more work before we simplify it again. That's why we always save our simplification to the very end, and we can't cancel out these until we get down to the very last step. So I know that was a lot of work for one problem, but the conjugate is something that we just have to keep working with as well, and just keep just practicing. So anytime you see a radical in your denominator now, we want to use this conjugate to get rid of it. You just multiply by the denominator, you're just flipping the sign in the middle. It's similar to what we did with the trig verifications with the sine and cosine, or like the 1 plus sine or 1 plus cosine. It's just we're using radicals now. So we should have one last problem. It's not nearly as long as the other one, where it shouldn't be, but it's cosine of 17 pi over 12. So cosine of 17 pi over 12. 17 pi over 12, that's something we don't know. It's not on our unit circle. So we can change it to something we do know, though. So we can multiply it by 2. So we have cosine. We multiply 17 by 2, it becomes 34 pi over 12 divided by 2. Does 34 pi over 12 simplify to something? We can take out a 2 from the top and a 2 from the bottom. Yeah, it's going to be 17 pi over 6 divided by 2. That's still the same. Do we know the value of 17 pi over 6, though? Is that on a unit circle? No. But we can find the coterminal angle of 17 pi over 6 that we do know. Because 17 pi over 6 is just a rotation past what we typically use. So, do we remember how to find coterminal angles?
Oh, we had 2 pi over 1, but we like to get the denominator.
So, in this case, we're going to subtract because we're looking for something on the unit circle, but we could either add or subtract to find a coterminal angle. So we have 17 pi over 6, and we need to subtract by 2 pi in order to get this, or in order to find a coterminal angle. But like you said, we need a common denominator. So if we put this common denominator as 6, what do we need to make our numerator? 12. So then what would our coterminal angle be? It's going to be 5 pi over 6. So we know that the cosine of 17 pi over 12 is the same as the cosine of 5 pi over 6 divided by 2. So this works for coterminal angles as well. And now we can use our formula to answer this. So with 17 pi over 12, what quadrant is that going to be? Not 2. What? Not 1. So 17 divided by 12. It should be third quadrant, if I'm not mistaken. Yeah. So 17 pi over 12, that's in the third quadrant. So is cosine positive or negative in the third quadrant? Negative. So we're going to have a negative in front. And then if we look back at our formula, up top, it says 1 plus cosine of theta over 2. So we're going to take 1 plus the cosine of 5 pi over 6, all divided by 2. That's our half angle identity for cosine. We have the negative out front because we know 17 pi over 12 is in the third quadrant, which cosine's negative in. What's the cosine of 5 pi over 6? I mean, negative radical 3 over 2. So we have negative the square root of 1 plus negative radical 3 over 2 divided by 2. Once again, we need to find the common denominator, but we have 2 as our denominator, so we know 1 is going to be 2 over 2 again. and then it's minus radical 3 over 2. So we found our common denominator. So what does our numerator simplify to then? As one whole fraction. So it's going to be 2 minus radical 3 over 2 divided by 2. So now we have a fraction on the top and a fraction in our denominator. So we can divide by the fraction, so we can flip the second and multiply. So this is going to become negative square root 2 minus radical 3 over 2 multiplied by 1 over 2. We're dividing by fractions, don't ask why. Flip the second and multiply. So what does this become? Minus radical 3 over 4. 2 minus radical 3 times 1. It's anything multiplied by 1 is itself, so it's 2 minus radical 3. And 2 times 2 is 4. So when we multiply by fractions, we multiply straight across. Top by top, bottom by bottom. Can we simplify 2 minus radical 3 over 4? So this becomes radical 2 minus radical 3 over radical 4. We can take the square root of the top and square root of the bottom. And the square root of the denominator, we know, is going to be 2. So we have negative square root of 2 minus radical 3 divided by 2.